Okay, this is a sample problem where gas molecules move in a cylindrical container with a circular piston. The molecules collide continuously with the piston, exerting a force on the piston and therefore causing a pressure in the container. The question gives the height of the cylinder as well as its cross-sectional area. It also gives the number of moles of this molecule in the container, as well as the temperature in the container and the number of the molecules. The first part of the question, part A, asks to calculate the RMS speed of the molecules in the container. So to calculate the speed of the molecules, I'm going to use the definition of pressure. Pressure exerted on the piston is defined as force over area. And the reason why these molecules exert a force on the piston is that they collide with the piston and when they change their momentum. So force is defined as the change in little p, where little p stands for momentum, not to be confused with big P for pressure. So force is the change in momentum over delta t, the change in time. In this question, we're given the time as 1 second. Now, because the mass of the molecule isn't changing, their change in momentum is just their mass times their change in velocity. So for a single molecule, it's going to travel upwards at v, and it's going to collide and rebound elastically at the same speed. So for its change in velocity, since velocity is a vector, is going to be 2 times its speed because it switches direction and its velocity switches by 2v, whereas the speed would switch by 0. So substituting that in here, I get 2 mv over 1 second. So the force for one molecule is 2 mv. Now the question gives that every second there's a number n of these molecules. So the force for an n amount of molecules becomes 2 nmv. Now I'm going to go back here and plug in the expression for force. And I get that. Now for pressure, I'm not given the pressure P. I am given the dimensions of the container, as well as the temperature in the container and the number of moles. So I can use the ideal gas law, PV equals nRT. So pressure would be nRT over the volume of the container. Now the volume of the container, an expression for V isn't given, but we are given H, the height of the container, and A, the cross-sectional area. And since this is a cylinder, the volume is the cross-sectional area times the height, which gives me that there. So the pressure is nRT over volume, and that equals the force over area. The force was 2 nmv over the area. Both sides here have area. So when I solve for velocity, I get nRT over 2 nmh. Okay, part 2 says that the pressure of the gas in the container is going to cause the piston of the container to accelerate upwards, and it asks to calculate an expression for that acceleration in terms of the given quantities. In this case, I'm also working with m, the mass of the piston, and also with atmospheric pressure, P sub 0. The first step in calculating acceleration, as always in physics, is to draw a free body diagram of all the forces acting on the piston. The first force, the gas molecules collide upwards with the piston and bounce down off of it. So there's an upward force of the gas. The piston does have a mass of m. So there's a force of gravity, mg, acting downwards on the piston. And last, there is a force caused by this atmospheric pressure. Now, the air molecules above the piston are going to collide at a much lesser rate than the molecules in the piston. So the net force is going to be upwards, but there is still a downward force caused by the atmosphere on the piston. Okay, now applying Newton's second law, the net force equals ma. Newton's second law says to set the sum of the forces in the direction of motion to ma. So the direction of motion in this case is given as upwards. So that makes the force of the gas, which is in the direction of motion, positive, while gravity and atmospheric force, which both act against the direction of motion, are negative forces. So that's given the sum of the forces. Now, since pressure is force over area, I get then that the force, and this is both for the gas and for the atmosphere, is pressure times area. Okay, so atmospheric pressure is given as P sub 0. That part's simple. The expression for the pressure of the gas I got from part A. This is from the ideal gas law, PV equals nRT, where again the volume was given as the height of the cylinder times the cross-sectional area. And solving for acceleration, I get this expression here. nRT over mh is the acceleration due to the gas. P sub 0 a over m is the acceleration due to the atmosphere, minus g, the acceleration due to gravity, and that gives the total acceleration of the piston upwards.